Hi guys, get ready for the stupidest lesson ever. This is vertical shifts, Unit 3, Lesson 7. This has 99 slides and it is the simplest concept in the world. You're not going to need to watch the whole thing, I promise. Definitions. A transformation is a change in the position or shape of an object or a graph of a function. A translation, which is what we're working on today, is a type of transformation that moves or shifts an object without changing its shape, size, or orientation. So all it's doing is taking the exact line or parabola or whatever you have and shifting it around. And today we're only shifting up and down. Okay, this is why this is so easy. So a vertical translation is when y equals fx plus k shifts the graph of y equals f of x up k units. So if it's plus k, it goes up. If it's minus k, it goes down. That is the whole concept for this whole lesson that they beat the poor dead horse over and over and over and over with. Okay, this is not hard. Once you feel like you've got this, you're fine because it gets really annoying. Okay, so remember this is y equals mx plus b. So if it's plus b, it moves up the y-axis. If it's negative minus b, negative b, it moves down the y-axis. Okay, here's example 1. Use a table and a graph to show that the function f of x is equal to x plus 2. It's translated up 2 units from the parent function f of x is equal to x. It's going to go through all of this complicated stuff to show you, to prove to you that this plus 2 means that this parent formula, which is just f of x equals x, goes up 2 units. That's all we're doing. Okay, it's going to go through and prove this to you. So step 1, the input variable is x. Okay, this is our input. The output variable is y equals f of x. F of x and y are interchangeable terms. Okay, so step 1, select input values for the input variable. These are the values that they selected. Okay, step 2 is evaluate the function using the input values to determine the output values. I had forgotten this. I made this yesterday. So we're starting with the parent function, which is simply f of x is equal to x. Okay, so that just means that these values are going straight across. So it's just -3, -2, -1, 0, 1, 2, 3, okay, through the whole thing. And you can see that here, because if f of x is equal to x, then the numbers are the same for the whole thing. So again, with the parent function, which is just this much of it, okay, you're going to get ordered pairs, which are right here, which can then be graphed. Okay, so you graph them, and this is what it looks like. And again, don't worry about, going through all the effort to graph this by hand. If you want to, you can go use GeoGebra. I think there's one question at the end that they want you to graph it, and I'll show you how to do that with GeoGebra. Work smarter, not harder. So step 4 is to plot the ordered pairs, connect them, and label the graph. Okay, so this is what the graph looks like, and you would label it f of x is equal to x, so that you know that this is the parent function. This is the first graph that you're dealing with. Now we're going to do the whole thing again for the translated function. This is when you take f of x is equal to x. Our first x is -3 plus 2. -3 plus 2 gives us -1, which you can see right here. Okay, you would do this for every value down this chart. So I'm just using this formula right here. I'm using the entire translated formula this time, not the parent formula. Okay, so let's do number 2. Okay, so x equals 2, and the rest of the problem is plus 2. So that's going to give us 4, and you can see that's the point they have right there. That's how you get all those points for this table. Okay, and then you would graph it just as you did before. And then we're going to compare the two graphs. This is the parent function. This is the original, just f of x is equal to x. You can see it crosses straight through the origin right there. All right. And this is the translated function. You can see it doesn't cross through the origin anymore. So now later we're going to interpret what that means, but this just proves that all they did was took this line and moved it up 1, 2 units on the y-axis. Okay. So this is proof that when you have a formula like this, which is really the standard formula of y equals mx plus b, this plus or minus b is all we're looking at today, and that determines if it moves up On the y-axis, y minus b means it would move down that number on the y-axis. Okay, we'll keep going. Here's example 2. Use a table and a graph to show that the function f of x is equal to x minus 3 is translated 3 units down from the parent function f of x is equal to x. There's our parent function. Here's our translated function. So we would do all the same steps that we just did. You first select input values for the input variable. These are the numbers they selected. Then you're going to evaluate the function using the input values to determine the output values. We're starting with the parent function. This is literally saying f of x is equal to x, so all the numbers are going to be exactly the same. Okay? These 2 points are a coordinate pair that you can then graph. That stands for the entire table, okay? So that you can graph it, connect it, and label it. Okay, this is what it looks like. This is the parent function, and parent functions always cross through the origin or touch the origin. Okay, now we need to do all the same steps for the translated function. Okay, the translated function is the one that has that b part, y equals mx plus b. It says minus 3, so everything's going to be moved down 3. So we'll take our first x value, which is negative 3. We would go f of x equals negative 3. That's our first x value. Minus 3. Negative 3 minus 3 is negative 6. You would do that for this whole table. Okay, and you can see all of our answers here. We now have coordinate pairs that we can graph. Okay, and we take those and we graph them, and this is what it looks like. Okay, before it crossed through the origin right here, you can see now it's intercepting the y-axis at negative 3. Let's compare the 2 graphs. Here it's crossing through the origin, here it's crossing at negative 3, which means it moved down 3 units, which is exactly what y equals mx plus b means. Or, in this case, we had a negative b, so it went down b units, which in this case happened to be 3. It went down 3 units. Everything else about the line stayed the same. Same slope, same size, everything else. Okay. Example 3. Use a table and graph to show the function f of x is equal to x squared minus 1 is translated down 1 unit from the parent function f of x is equal to x squared. Here's our parent. Here is our translated. Okay. The only thing that matters in the translation is this number. So first you're going to figure out your x coordinates. This is what they used. Okay, and then you're going to figure out your f of x coordinates, and guess what? For the parent function, this x squared, f of x is equal to x squared. So it's going to be this number squared to get the right coordinates. Okay, so negative 3 times negative 3 becomes positive 9. Negative 2 times negative 2 becomes positive 4. Okay, and you're going to see that all the way down this whole chart. Okay, now we're going to take our coordinate pairs and we're going to plot them, and this gives us a parabola, which we should see with any x squared formula. Okay, this is our parent function. It's touching the origin right there. Now we need to do all of the same junk for the translated function. So now we have this formula. So we have f of x is equal to x squared. We'll use our first x, which is negative 3, minus 1. Negative 3 times negative 3 is positive 9. Positive 9 minus 1 gives us 8. That's how you figure out all of these. Okay, that gives you your coordinate pairs, which you can then graph. Okay, before it was touching the origin, now it's down 1 unit, which is exactly what we should see from this translated function. Okay. This lesson took forever to do and forever to put together. Thankfully, it's going fast. Here's example 4. Use a table and a graph to show that the function f of x is equal to the absolute value of x minus 4 is translated down 4 units from the parent function f of x is equal to the absolute value of x. These absolute value signs we haven't seen yet in this math course. It just means that x is positive no matter what the number is. Okay. The input variable is x and the output variable is y equals f of x. So select input values for the output variable. Okay, this is easy. If if f of x is equal to the absolute value of x, then it just means it's positive x no matter what. So this has to be 3. This has to be 2, this has to be 1, all the way down. It's always positive, okay? So 3, 2, 1, 0, 1, 2, 3, okay? Then we have our ordered pairs, which we can then graph, and you can see on this parent function, it's touching the origin, okay? Now we need to do the translated function, which is this one right here. So we're going to have f of x is equal to the absolute value of our first coordinate is negative 3 minus 4. The absolute value of 3 is positive 3. 3 minus 4 gives us negative 1. You would do that same process for this whole table, okay? There's all of our coordinate points. You go ahead and graph it, and you can see it was touching the origin before, and now it's moved down 4 units, which is exactly what we should see, okay? You can see that here, touching the origin, down 1, 2, 3, 4, because we're dealing with negative 4 in the B position. Your turn. Question number 1. Use a table and a graph to show the function f of x equals x cubed plus 1 is translated up 1 unit from its parent function f of x equals x cubed. Pause the video, do it, come back. So the first thing you have to do is get your x values and do it for the parent function. And the parent function says f of x is equal to x cubed. So x cubed is negative 2 times negative 2 is positive 4 times negative 2 becomes negative 8. Negative 1 times negative 1 is positive 1 times negative 1 is negative 1. 0 times itself is always 0 no matter how many times you do it. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So that's what your chart should look like. These are coordinate pairs that you can then graph. So your parent function is going to look like that, okay? Then we need to do the same thing for the translated function. So now we have f of x is equal to x, which is negative 2, cubed plus 1. Now I'm all for working smarter, not harder. We already have all of our values for x cubed, which is right here. So all we're going to do is add 1 to each of these. So negative 8 becomes negative 7. Negative 1 becomes 0. 0 becomes 1. 1 becomes 2. And 8 becomes 9. Why make it harder than you have to? Okay. So that gives us coordinate pairs, which we can then graph, which gives us this. And we can compare the two. You can see the parent function goes right through the origin, and the translated one moves up 1, which is exactly what we should see because we have plus 1. Okay. Here's question number 2. That's all you. Use a table and a graph to show that the function f of x equals the square root of x minus 2 is translated 2 units down from the parent function f of x is equal to the square root of x. Go ahead and pause the video and do it. All right, so the points that they chose, because we need nice numbers that do beautiful square roots, are 0, 1, 4, and 9. So f of x is equal to the square root of x. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. There's our coordinate pairs, which you can graph. There's our parent function. If I'm going too fast for any of this, please comment down below what color the slide is and what the title of the slide is, and I will go back and slow it down for you. Now we need to do the translated one, which is the square root of x minus 2. Okay, so the square root of 0 is 0, minus 2 becomes negative 2, square root of 1 is 1, minus 2 becomes negative 1, square root of 4 is 2, minus 2 becomes 0, square root of 9 is 3, minus 2 becomes 1. So here's our new coordinate pairs and our new graph, and you can see that it started at the origin for the parent function and it moved down 1, 2, which is exactly what we should see. Can you see why this lesson feels like it's beating a dead horse? We're only halfway through, and it's like, okay, you could have just told me from the beginning that this means it moves up and down and we're done, but no, it's going to keep going. How to identify a vertical shift. Step 1, compare the equation of the given function and its parent function. Determine all the differences. Step 2, compare the graph of the given function and its parent function. Determine all the differences. Step 3, use the results from step 1 and step 2 to identify k and the effect of the vertical shift on the parent function. Here's example 1. Use the graph and the equation f of x equals x plus 1 to identify the vertical shift k and the effect it has on the parent function. Okay, so step 1, compare the equation of the given function and its parent function. So this is the given function, this is the translated one, and its parent function does not have this plus 1. So the difference is that the translated function has plus 1, therefore k equals 1. Pretty straightforward. Okay, k equals whatever this number is. You need to add the sign in. That's the only thing that might trip you up. Okay. Step 2, compare the graph of the given function and its parent function. Determine the differences. This is the parent function because it goes through the origin. This is the translated function because guess what? That plus 1 moved it up 1 unit. Notice that the graph, the translated graph, is moved up 1 unit from the parent function. Step 3, use the results from step 1 and step 2 to identify k and the effect of the vertical shift on the parent function. The function f of x equals x plus 1 has a vertical shift of k equals 1. Okay, we discovered that in our first step. The effect is that the graph moves up 1 unit from the parent function. There is no change in the size or shape of the graph. This didn't suddenly become bigger or anything like that. Okay, it's going to do the same thing over and over and over again. Example 2, use the graph and the equation f of x equals x minus 2, which is our translated function, to identify the vertical shift k and the effect it has on the parent function. The vertical shift is simply this extra number. The parent function is just f of x equals x, and anything that might be attached to x, like a square root or an exponent. Okay, so that means k is -2. That easy. Don't overthink it. Okay, so here's both graphs, the parent function and the translated function. It means you take the parent function that goes through the origin and everything moves down 2 units, which is what is shown by the value of k. And if you look at them, you can see everything we just talked about. There's no change in slope. It's still rise 1, run 1, rise 1, run 1. There's no change in size. The y-intercept changed here. The y-intercept was 0, 0. And here the y-intercept is -2, 0, -2. Okay, that changed, but the slope did not change. Example number 3, use the graph and the equation f of x is equal to x squared plus 2 to identify the vertical shift k and the effect it has on the parent function. The parent function stops before your k. So this is the parent function. This is k. So the value of k is 2, positive 2. Okay. These are what the graphs look like. The parent function touches the origin, and the translated function moves up 2 units. Everything else stays the same. The only thing that changes is the y-intercept. Okay, here's a check-in. What is the effect of the vertical shift on a function y equals f of x if k is a positive number and the translated function has the form y equals f of x plus k? What's going to happen to this translated form compared to the parent form? It's going to move up k number of units. Example number 4, use the graph and the equation f of x equals the cube root of x minus 1 to identify the vertical shift k and the effect it has on the parent function. So identify k. Guess what? It's right there. It's -1. We are so smart. And what that means is that the parent function crosses through 0, 0, and the translated function moved down 1, so it crosses through 0, -1. Everything else stays the same. The whole thing just dropped 1 space. Okay, there's no change in slope. The x-intercepts and y-intercepts might change. Here the x-intercept was 0, 0, and here the x-intercept is 1, 0. But I mean, the line itself did not change. Okay, what is the effect of the vertical shift on a y-intercept function if y equals f of x if k is a negative number and the translated function has the form y equals f of x minus k? What's it going to do, guys? It's going to move down the number of units that k is, right? However many k is, that's how many it's going to move down. The y and x-intercepts might change, but the y-intercept will for sure. The x-intercept might, depending on the problem. Now I need you to take a moment and look at this. That's the most beautiful axolotl I've ever seen. Use the graph and equation f of x equals the absolute value of x plus 3 to identify the vertical shift k and the effect it has on the parent function. Note any effects on the intercepts of the function. Pause the video, do it, come back. So compare the equation of the given function and the parent function, determine the differences. So the parent function stops right there. It's just f of x equals the absolute value of x. So the difference is this plus 3, which is our k value. That means k equals 3. That means that this parent function is going to move up 3 units, which we can see on these two graphs. Here it touches the origin. Here it went up 1, 2, 3. The V shape stayed exactly the same, but it shifted up 3 units. Okay. There's no change in the size or shape of the graph. The original function had an x-intercept and y-intercept at the point 0, 0. The translated function no longer has an x-intercept. It does not intercept this x-line at all and has a y-intercept at 0, 3. Okay. Here's question 2, which is your turn. Use the graph and the equation f of x is equal to x cubed minus 3 to identify the vertical shift k and the effect it has on the parent function. Determine the location of the new y-intercept. Okay, so this one, pause the video, go do it, come back. Here is the parent function, everything over here. This is the difference, which means that k equals negative 3. So the location of the new y-intercept is tonk, 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 negative 3. Okay. So you can see here that originally it's at 0, 0, and now it went 1, 2, 3, and now the y-intercept is at 0, negative 3, which we just established. Here is the third part of the lesson, example number 1. Now we're not dealing with the parent function. We're not starting with the parent function. We're starting with the translated one. The graph shows the function f of x equals x plus 3, which makes sense because this is the parent function and it moved up 3 units. If it undergoes a translation using the rule f of x equals 7, describe the translation and write the equation of the translated function. So we're taking an already translated function and we're translating it more. Okay. The original function will be translated down 7 units because it's f of x minus 7. Okay. So how we do this is we do f of x equals x plus 3, which is our original formula, and then we throw in our minus 7, which is our next step. Okay. Then we simplify. 3 minus 7 is minus 4. So we have f of x equals x minus 4. The slope of the translated function remains the same. The slope is what is attached to x. And the y-intercept changes. The original y-intercept was located at 0, 3. After the translation of 7 units down, it's located at negative 4. So you could literally just go 1, 2, 3, 4, 5, 6, 7 and do it that way too. Okay? You can do the math way or you can just count down 7 because we're subtracting 7. Here's example 2. The function f of x is equal to x squared minus 3 is graphed. If the graph is mapped onto the function g of x is equal to x squared plus 9, describe the translation. What will be the effect on the intercepts of the quadratic function? We're starting with a translated one, and then we're going to another translated one. What's going to happen to it? To translate the function f of x, which is here, to g of x, it must be translated up 12 units because we're going from negative 3, which is right here, to positive 9, which is right here. Okay. So you could do this by math. You could do, you do minus 3 plus 9 and figure it out that way, or I would count. That's the way I am. Okay. I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, I miscounted. It's 12. The y-intercept will move from the point 0, 3 to 0, 9, and the x-coordinate, the y coordinate will increase by 12. There will be no x-intercepts of the translated function because the graph will be entirely above the y-axis. It'll be clear up here. So the new one, g of x, isn't going to have any x-intercepts. So the way I would figure it is not this. I would do, we started at 0, -3, and we're going to 0, 9. So what's the difference between these two? We have 3 here to go from 3 to 0, so 3 plus 9 is 12. Okay. Here's example 3. The function f of x is equal to the square root of x is translated to create the function in the graph. So we have a translated function here, and here is its formula. They didn't tell us over here. Determine the value of k of the translation and relate it to the equation on the graph. Well, the value of k is right there. It's +2. And it means that the graph shifted up 2 units from the parent formula, which is this. Okay. So this goes through and tells you all of the points it has, which you can see right here. So that's not hard to do. And it means that they all moved up to, originally it would be 0, 0, and then it would come down to, so it would be 1, 1. Okay, you could go across the whole way and do that. Question 1, your turn. And yes, it gave me that picture for an axolotl. Don't ask me why. The function f of x is equal to x cubed minus 2 is the result of a translation 4 units down from the original function g of x, which is not pictured. Where was the y-intercept of the original function located? Okay, so this is giving you the new one, and it wants to know where the old one was. This has been translated down 4. Pause it, figure it out, come back. So the way I would figure this out is the old one, the new one is 4 units down, so I need to go 4 units up to find the new one. So -1, 0, 1, 2. The old y-intercept was at 0, 2. Okay? That's the easiest way for me to do it. I'm sure there's much more complicated ways to do that, but this is the original graph. And they showed all of the points, but there's nothing like this on the end that you need to find all of the points, so don't worry. Oh, look at this. I'm sorry, I went to the wrong chart. So the original y-intercept would be located at 0, 2. Since the function that was graphed was translated 4 units down from the original function g of x, the original function would be located 4 units higher on the graph. Move the y-intercept to 0, -2 up 4 units to the original position at 0, 2. Here's question 2. They also gave me this picture for an axolotl. The function f of x is equal to the absolute value of x plus 4 is translated using the rule f of x plus 3. Write the equation of the translated function and determine where the point 37 is mapped to. Okay, so this is a multi-step problem. So this is the formula that it's talking about. It's showing us this formula, and we're going to translate it using this rule. Okay, so pause the video, figure it out, come back. So how you do this is you take your original formula equals the absolute value of x plus 4, and then we're going to add on this rule and add another 3. So that our new formula is going to be f of x is equal to the absolute value of x plus 7. Okay? And determine where the point 37 is. So everything is getting translated up 7. We already did 4, so in my brain that means we go up 3 more. 1, 2, 3. Okay, so that means that this point 37 is now going to be 310. Let's see if I'm right. So the new equation is correct, and 37 will become 310. Only the y-coordinate changes. You don't mess with the x-coordinate because it's not shifting side to side. It's only shifting up and down. Very end of the lesson. Practice question number 1, and this is where things start to get scary because it gave me some seriously creepy axolotls. The graphs of the function f of x is equal to 1/2 x, which is the orange solid line, and g of x is equal to f of x plus 2, which is the dotted blue line, are shown. How does adding 2 to f of x impact the graph? Okay, so they wrote this wrong. No, they didn't, I guess, because f of x is all of this. So it's all of this plus 2. It translates the graph up 2 units. It translates the graph down 2 units. It reflects the graph over the x-axis and translates up 2 units. Speed round. Which one is it? Which one is it? Well, we're not doing side to side, so that one has to be gone. So did it translate it up or down? It's positive. So it went up. These are not necessarily in the same order on your practice, so don't just pick the first one, read them. Practice question number 2. Two tables were generated to compare the functions f of x and g of x equals f of x minus 1. Find the missing value in the table for the function g of x. So this is our original one. We have 0, 0, negative 1, 1, 2, and 4. And our next one is 0, negative 1, negative 1 something, and 2, 3. So the easiest way for me to do this is to create a graph. So we have 0, 0. Woo-hoo-hoo. We have negative 1 and 1. And we have 2 and 1, 2, 3, 4. So this is interesting. I'm not sure how to connect these. We start at 0. We go here and we go like this. So maybe it's a parabola that's like sideways like this. We'll pretend that's what it is. And my next one is, I'm going to draw it down here because I drew it kind of sloppy, is 0, negative 1. So our first point is here. And then we have negative 1 and something. And then we have 1, 2, and 1, 2, 3. Okay. So this one moved down 1. Okay. We don't know about this one. And this one went from 2, 4 to 2, 3. So it moved down 1. So this one's going to move down 1. So it's just 1 down to 0. Okay. You may not have needed to do all of this, but I'm a very visual person. You could have probably done it with just math, but that's how I figured it. Practice question 3. Wow, he's scary. The graph shows a parent function y equals f of x, which is the solid orange line, and its translated form y equals f of x plus k, which is the dotted blue line, which has undergone a vertical shift. Use the graph to find the value of k. Speed round. We started here. Now we're here. What's the value of k? Well, it went down, so it's negative, and it went down 2, so k is negative 2. Here's practice question number 4. The graph shows a parent function as a solid line, which is orange, and the translated function as a dotted line, which is blue. Describe the effect that transformation has on the equation of the parent function f of x is equal to x, the absolute value of x, by determining the value of k in the translated function. Here's our parent function, because it's touching the origin. And here's our new one. What's the value of k? Speed round. Well, it's going up, so it's positive. And how many did it go up? 3. Value of k is 3. Practice question number 5. This looks like something straight out of Stranger Things. The function graphed with a blue dotted line is translated to the function graphed as a solid orange line. So we're going from blue to orange. Okay, we're going this direction. It's doing it opposite. If the same translation were applied to the solid orange function, what would be the coordinates of the new y-intercept? So we went from here to here. So what's the k value there? That's positive 3. And now they want to do it again. So we go up 1, 2, 3. The coordinates of the new y-intercept would be 0, 3. Here's quick checks. I won't give you the answer to these ones, but I will tell you how to find it. He's super scary too. Which statement best shows how the vertical shift affects the parent function y equals x when shifted to y equals x plus 5? And I didn't put the answers in here because I'm a genius. But how does the vertical shift affect this when we shift here? What is the vertical shift doing? Well, the only thing that matters is the k value. What is the k value doing? You should be able to answer this. Quick check question number 2. Which graph accurately demonstrates the relationship between the functions f of x equals the square root of x and f of x equals the square root of x plus 3? Okay, so one is going to show this, one of these lines is going to show the parent function, and parent functions always touch what? Okay, and then one is going to show the translated function, which is going to move either up or down 3. So pick the correct one here. Quick check question number 3. Determine the x-intercepts of the function that translates the original function f of x equals x squared down 4 units. So this one is going to require GeoGebra. GeoGebra.com, start your calculator, and the formula it gives us is I can do this. I'm screwing up everything. F of x is equal to x squared, and then it wants us to move this parent function down 4. I would hope I'm not cheating to tell you that moving it down means negative, and 4 is the number we're moving it down. Now it wants to know what the x coordinates are for this problem. You just go ahead and select whichever one of these is the correct answer. Quick check question number 4. Wow, this one is scary. Describe the transformation that occurs on a graph when changing an equation from f of x equals negative absolute value of x to f of x equals negative absolute value of x plus 4. I will tell you this much because we haven't really dealt with absolute values yet. An absolute value means whatever the value of x is means that x is going to be positive. But because this negative is outside of it, it's going to be negative. So this is like the opposite of an absolute value. So no matter what this x is, the value is going to be negative plus 4, okay? So describe the transformation that occurs when changing an equation from this to this. Again, the only thing that matters is the k value. Pick which one of these is correct. Quick check question number 5. The image shows a parent function. Wow, it shifted on me. There's the parent function and a translated form. Which statement best describes this translation? Okay, so we have the original, which touches the origin, and we have the changed one, which is right down here. Which best describes this translation? Pick the correct one there. And this is to the creepy axolotls that they showed me, and I'm not even looking because they creep me out so bad. But this one is the least creepy of them all, and I could not stand to put it on a slide because it looks like it's going to eat your face. Okay, bye guys.